Black holes, huh? They're like the ultimate cosmic mystery, right? These invisible things just warped the fabric of space and time. Wild. So today we're going deep into the world of black holes. We're using excerpts from, you guessed it, Wikipedia to try and figure out what's real and what's, well, science fiction.
Yeah, it's really amazing how much we've learned about them.
Yeah.
It's funny, even Einstein, the guy who basically wrote the book on relativity, he wasn't even sure they were real at first.
Really? Even Einstein, I mean, it does sound pretty wild when you try to, picture it.
It definitely messes with your brain a bit.
Okay, so speaking of things that are hard to wrap your head around, the Wikipedia article mentions space-time a lot. What is that exactly? Sounds kind of like something out of Star Trek.
Yeah, it can be a bit tough to visualize. Think of it this way. Imagine space-time as like the fabric of the universe. It's where space and time are kind of like woven together. Now imagine you take a bowling ball and plop it onto a trampoline.
Okay, I'm picturing it.
That's sort of what a black hole does.
Uh,
Its mass is so dense, it warps that fabric, creating this like gravitational well that's so deep, absolutely nothing, not even light, can climb out.
Whoa, okay, so that point of no return, that's the event horizon, right? It's like a cosmic trap door.
Exactly. When something crosses that line, it's game over. Things get really, really weird.
Speaking of weird, the article mentions something called Hawking radiation. So it's like black holes aren't actually black.
It's true. Stephen Hawking, brilliant physicist, he proposed that black holes actually emit a tiny, tiny amount of radiation. It's due to some quantum effects happening near the event horizon.
So they kind of slowly evaporate over time.
Exactly. Over incredibly long timescales. We're talking way longer than the current age of the universe, but yeah.
Wow. I always thought black holes were just these eternal things, like cosmic vacuum cleaners that just sucked everything up
A
forever.
common misconception.
Okay, so if these things are defined by how much gravity they have, does that mean all black holes are basically the same?
That's where things get even more interesting. Black holes, even though they seem super complex, can actually be defined by just three things.
Three things, really?
Yep, just three.
Yeah.
Their mass, how much electrical charge they have, and how fast they're spinning.
So you're saying all the complexity of a star, its whole history just gets boiled down to how heavy it is, if it has a charge, and how fast it's spinning.
Pretty much. It's a
Wild.
pretty mind-blowing idea called the no-hair theorem. It's like saying a black hole is bald. It's stripped of everything else, no matter what it was before.
That almost sounds too simple. But okay, hold on. Before we get ahead of ourselves, let's talk about how these things even form. The article says it's from collapsing stars, right?
That's the most common way, yeah. Picture this. You've got a massive star, way bigger than our sun, and it's reaching the end of its life. It's run out of fuel, and suddenly, boom, its core collapses in on itself because of its own gravity.
So like a cosmic swan dive.
You could say that. That implosion creates the black hole. And the ones formed from stars, those are called stellar mass black holes. Right, but those aren't the only kind. There are also these supermassive black holes, and they're, well, supermassive. We're talking millions, even billions of times the mass of our sun. Those hang out at the centers of galaxies.
Okay, so we've got these stellar mass black holes, right?
Yeah.
The ones from dying stars. And then on the other end of the spectrum, there are the supermassive ones. But what about in between? Are there any mid-sized black holes? Did the Wikipedia article say anything about that?
Yeah, actually, it did mention something called intermediate mass black holes. They're still kind of a puzzle.
A puzzle how?
Well, we think they might form when smaller black holes smash together in these really dense star clusters. But be honest, there's still a lot we don't really know about how they form and how they change over time.
So like a missing link in the black hole family tree. I like it. But here's another thing that's always bugged me. If we can't even see black holes directly, how do we know they're actually out there? It's not like we can just, point a telescope at them and be like, yep, there's one.
That's a great question, and it kind of highlights how clever astronomers have gotten. See, they've figured out all these ways to observe the effects of black holes, even if we can't see the black holes themselves.
Effects? What do you mean?
Well, take Sagittarius A, for example.
Yeah.
It's this mysterious radio source right at the heart of our galaxy, the Milky Way.
Okay, I've heard of that.
So, by watching how stars orbit around Sagittarius A, astronomers realized that there has to be something incredibly massive there, something invisible, and that something, well, it's most likely a supermassive black hole.
So it's like we're seeing the footprints of these gravitational monsters, but not the monsters themselves.
Exactly. It's cosmic detective work. And get this, in 2019, the Event Horizon Telescope, they actually captured the first ever image of a black hole shadow.
No way. So we've actually kind of seen one.
Well, not directly. It wasn't like seeing the black hole itself. It was more like seeing the light bending around it. Created this silhouette against a really bright background.
Still, that's pretty amazing. Oh, and speaking of amazing, the article also mentioned gravitational waves, right? Those were a big deal for proving black holes exist, weren't they?
Absolutely. A total game changer.
Yeah.
Detecting those waves back in 2015, it was like, whoa, we're actually listening to the universe ripple. It proved that black holes aren't just some mathematical idea. They're out there and they're doing some crazy stuff.
Okay, so we've talked about what they are, how they form, how we even know they exist. But what about this spaghettification thing? That sounds kind of terrifying, to be honest.
Yeah, that's definitely one way to put it.
So, like, what would actually happen?
Imagine you are falling towards a black hole, feet first.
Okay, I'm imagining it. Not sure I want to, but go on.
So as you get closer and closer, the gravitational pull on your feet, it would get way stronger than the pull on your head.
Oh, I see where this is going.
You'd basically get stretched out like spaghetti, hence the name.
Not my ideal way to go. Yikes. But it shows you just how extreme the gravity is near a black hole, right?
Exactly. It's hard to even wrap your head around.
You know, with all this talk about spaghetti and cosmic trapdoors, it still feels like we're talking about something out of a science fiction movie.
I know, right? And the crazy thing is, there's still so much we don't know.
I mean, it's just crazy, you know? We're talking about these things, these black holes that were once just theoretical, and now look at us talking about them stretching you out like spaghetti.
It's pretty wild when you think about it that way, isn't it?
Yeah, it really is. It's amazing how much we've learned about them.
Totally. From those early days when even Einstein was skeptical to actually detecting those gravitational waves, it's been an incredible journey.
Absolutely. But are we done? I mean, are there still big mysteries about black holes that, like, keep physicists up at night?
Oh, definitely. Tons of them. We're still just getting started, really. There's still so much we don't understand.
Okay, well, since you brought it up, let's talk about some of those mysteries then. Like, what happens to stuff that falls into a black hole? The information, I mean. Does it just, like, disappear forever?
But you see, that's the big question, isn't it? It's what we call the information paradox. One of the most basic rules of physics is that information can never be destroyed.
So, wait, you're saying that everything that falls into a black hole, every last bit of it, it leaves, like, a record somewhere?
That's the idea, yeah. In theory, at least. But the traditional way we think about black holes, it suggests everything gets completely obliterated once it crosses that event horizon.
But if information can't be destroyed?
Exactly. So where does it go? It's a huge puzzle, and we haven't figured it out yet.
Wow. Okay, so it's like the universe has this cosmic shredder, right? But somewhere, there's this mysterious filing cabinet with everything perfectly preserved.
Uh-huh. That's a great way to put it. Some physicists think that the information might be encoded in the Hawking radiation. You know, that stuff we were talking about earlier.
Oh, right. So even though the original thing is gone, it's like its ghost lives on in the radiation.
That's one possibility, yeah. Other physicists think we might need to rethink how we understand information altogether, especially when it comes to black holes.
It's incredible to think that these things, these black holes that used to be considered so simple, so destructive, they might actually hold the key to some of the biggest secrets in physics.
I know, right? Yeah. And that's what's so amazing. Black holes are these incredible enigmas that force us to confront the boundaries of what we know about the cosmos, about what's possible. They really push the limits of our understanding.
Well said. Well, as we wrap things up here, I think if there's one thing we can all agree on, it's that we still have a lot to learn about black holes.
We've only just scratched the surface.
Exactly. But hey, that's part of what makes them so fascinating, right?
Absolutely.
Black holes remind us that the universe is this place of endless wonder, of mystery, full of surprises, just waiting to be discovered.
Couldn't have said it better myself. And who knows what incredible things we'll discover next as we keep exploring these cosmic enigmas.
Exactly. So next time you need a reminder that sometimes truth really is stranger than fiction, just think about black holes. They're a testament to the sheer power of gravity, to the mysteries of the universe, and to our limitless human curiosity to explore the unknown.